Okay, let's take a look at the Level 2 Mathematics 212 paper, Probability Methods. The practice exam we used at Nelson College in 2018 for the 12 MSN courses. So, question 1. Right, let's see, what do we got? 416 passengers, data collected about personal accidents or loss items, given in here. Okay, what proportion of passengers on the flight had an accident on their last holiday? So, of all the passengers, 32 had an accident. And that's enough, we don't need to simplify that down at all. What proportion of passengers on the flight that lost items? So we're only looking at people that lost items, so it's just this block of people here, not the whole 416, were female. So the females who lost items, out of all that lost items, 16 out of 24. Okay, now, travel insurance company made the claim that females on holiday are twice as likely to lose items than males on holiday. Okay, so we need to look for the probability that a female on holiday loses an item. So that's a lost item given it's a female. So we're only looking at the females here. There are 259 of them and 16 lost an item. So 16 out of 259 lost an item, and we want to compare that to males on holiday losing an item. So the probability of a lost item given or for the males, well, out of the males is 157 in total, and 8 lost an item. Okay, so we need to compare those two probabilities. I'm going to turn these into decimal fractions just to make them a little bit easier to compare. So on the old trusty calculator, 16 divided by 259 is, so for females it's just over 6%, and for males 8 divided by 157, it's just over 5%, 0.0510. Okay, so I'm comparing those two. So the probability that lost item, that a female lost an item is 6% roughly, and the probability that a male lost an item is 5%. So it's nowhere near this twice. So we're going to calculate what we call a relative risk. I'm going to use this one here as my baseline for males and see what the female probability is compared to that. So the probability of lost item given female divided by my baseline risk, which is the probability that a male loses an item, is 0.0618 over 0.0510. 0.0618 divided by 0.0510, 1.21. So, can the claim be justified statistically? We need to use some figures. So claim is not justified females are only 21% more likely to lose an item than males, not 100% more likely as claimed. Oops, I've written that and you can't see it. Okay, so what I've written there, I've calculated the relative risk, 0.0618 divided by 0.0510, that's 1.21. So the claim that it's twice as likely is not justified. The females are only 21%, 1.21, 21% more likely to lose an item than males, not that the 100% more likely is claimed, because saying that it's twice as likely means the rate for females should be twice that of the males, so 100% more. Okay, let's go on to the rest of question 1. Okay, so here we've got a table and it's not filled out for us. It's the same 416 passengers and it's looking at their activities. Okay, we're told that 231 watched movies, so altogether that's 231, and 172 read books. So down here's 172, and 37 did not watch movies or read books. So they didn't watch a movie, they didn't read a book, so that's my 37 in there. So even before going on, I'm going to fill in the rest of this table. I know that this plus this must be that, so that's got to be 416 minus 231. 416 minus 231 is 185. So 185 didn't watch movies. This here will be 416 minus 172. Okay, 416 minus 172. 244. What else do we know? We know 37 didn't read books and didn't watch movies, but 244 now we know didn't read books. So these ones, the difference between these, must have watched a movie but not read a book. So that's 244 minus 37. 207. Okay, now we're running and laughing. Okay, let's go across this way. 185 didn't watch movies, of which 37 also didn't read books. So 185 minus 37 didn't watch a movie but did read a book. That's 148. And hopefully this balances out. 231 minus 207, they're the ones that watched movies and read books. So that looks like 24 going across there. And 172 minus 148, that also gives me 24. So I think that balances up quite nicely. Okay, now obviously I'm going to use this information later on. I think it's worth filling out the whole table. What proportion of the passengers read books and watched movies on the flights? So that's the one that read a book and watched a movie, so that's our 24 out of our total 416. We haven't restricted it anywhere now, so I've just worked backwards in my table, found that total and filled it right in. Okay, now we go on to the second part. The airline claims that passengers that don't read books on a flight are 6 times more likely to watch movies than those that do read books on a flight. So I need to compare the probability of someone watching a movie if they don't read, with watching a movie if they do read. So the probability of watching given that they don't read, so we're only looking at the don't read people, and that's 207 out of 244. And later on I'll do that decimal fraction for that one, and I need to compare the probability of watching given that they do read. Okay, so now we're looking at the ones that do read. The ones that watch is 24 out of 172, and they're the two I'm going to compare. And the baseline, because it's 6 times more likely than those that do read books, the do read books becomes my baseline. So this here's my baseline this time for my relative risk. Alright, let's grab the calculator and work these two out. 207 divided by 244 equals 0.8484. Bit hard to see that on the calculator there, isn't it? And 24 divided by 172 is 0.1395. So let's work out that relative risk. The probability of watching given don't read divided by the probability of watching given that they do read must be my 0.8484 over 0.1395, which is 0.8484 divided by 0.1395, 6.08. 6.08. Now the claim was 6 times my number, 6.08. That's pretty close. So I'm even going to say that's approximately 6. So claim can be justified statistically, i.e. the passengers that don't read books are 6 times more likely to watch movies than those that do. Than those that do watch. Sorry, that do read books. Okay, and that's pretty much question 1 done. So let's have a look at it now from a marking perspective. Got a copy of the mark schedule here. So let's see how we've gone. Question 1, part 1, proportion. So 32 over 416, we can see it there. That's going to give me a little U tick. So there's a little U. Okay, that's great. 16 over 24 for the second one. I'm going to get the full R tick there. And actually you can get a U tick if you've done the 16 over the 416. So that's the probability of someone, a female, losing an item out of all the passengers, whereas we only wanted to look at the passengers that lost an item. So that 416 is giving us the wrong base there to work with, isn't it? Okay, now for the travel insurance company. So getting either of these two would give me a little U. Okay, getting both of them but not concluding correctly, so both of those would give me a little R. Obviously you're not going to get the 2 U's and the R, you just get the R, you get the grade of what you get. And finally making the comparison, so the 1.21, and we can see in the mark schedule there, that's the 1.21 there they're looking for. Not close to 2, not justified, so I'm going to get all of that. I'm going to get a little T tick for myself there. Over in part B, straight up just reading it off, we've got that, you can just see it there, the 24 over 416, didn't need to simplify it. The probabilities found, so there's another little U tick. And then finally the piece about movies and not reading, movies and reading, the relative risk, and it's close. Okay, so one risk calculated, so either of those again would give us a little U. Both, but no sufficient conclusion. So actually getting those, which isn't that hard, is a little R, and the whole lot there, with your conclusion written in, is going to give us that T. And that's question 1.